It's a game of finesse, ultimately, and so the standards were primarily designed to support a set of specifications that would bound power and spin, which are two aspects of the sport that we don't want to see too much of.
Hello, welcome back to another episode of The Future of Pickleball. You're going to find this to be a very, very interesting segment we're going to do today. We have a guest on, Carl Schmits from USA Pickleball. Carl is the man that runs all of the testing, works with the standards for the equipment, for the game, for the facilities. We're going to cover all of that today, and candidly, we're going to try and cover it in a level of depth that you've never been able to see before. Carl's going to tell us about what they do, how the standards are set, and we're actually going to do a little bit of a test center tour as part of our interview today. Carl, welcome to the show.
Thank you, Paul. Appreciate being here.
You know, one of the things that I think an awful lot of our viewers would benefit from is really hearing from you what the standards are about, why they're important. I think we've got a few too many people that voice opinions that maybe are a little casual or unfounded. What was the basis of setting standards to begin with?
I think at a high level, our original board members wanted to ensure that basically the character of the sport was maintained, or the nature of the sport. And I think we would still characterize it this way today. It's a game of finesse, ultimately. And so the standards were primarily designed to support a set of specifications that would bound power and spin, which are two aspects of the sport that we don't want to see too much of. And so there are several different tests that are done to uphold different specifications, which include coefficient of friction, surface roughness, the overall deflection off the paddle face, the dimensioning of it, so the width plus length, and then of course how shiny they are. They can't be too reflective. And so these have evolved over the years. We have folded in new standards as it became clear that there were developments in coatings several years ago, and so the surface roughness test on its own wasn't adequate to bound the friction component, so we used a physics-based test. It's called coefficient of friction. We implemented that back in 2020, and then we're in the process of migrating the surface roughness test from a technology standpoint with the introduction of new textures on the face of paddles. This migration from a mechanical stylus type test to an optical, a 3D optical scan is in process now.
So for those of you, the physics test that Carl's talking about, I have seen done, and you guys are actually going to get a chance to see a lot of these things in a little later on in the show that Carl's talking about. It's really been interesting being a player, a person very involved in the sport, watching what has gone on. And would you say that the style of play has changed the need for standards, or have the standards changed the style of play?
I'd almost say neither. We've seen a level of athlete move into the sport and bring reach, bring power, foot speed that perhaps didn't exist in the earlier days. And so that's one component. The other component would be the advancement of materials and manufacturing processes. We've seen considerable movement forward in that in just the last few years. Up until it was 2018, late 2018, was with the introduction of the first molded resin face, what some refer to as raw carbon. And that was the only product of its type for 2.5 years. And then another couple of brands introduced their versions of that. And then now, the market's quite dense with that. And so you see, perhaps one technology applied, and the success of that is measured. And if it looks like both a commercial and competitive success, then many others adopt it. Now, if it's the one of a kind, will we create a standard around that? Probably not. But if it looks like it's going to drive a trend that may change the friction, for example, component or power, which is the main topic that people are looking at today, then we have to move more quickly in the research that we're doing, and we'll talk about coefficient of restitution at some point.
Perfect. And actually, on that order, one of the things with the work that I do with Selkirk in my traveling and interfacing with a lot of on-court players and trying products and showing new products, we talk a great deal about what the coefficient of friction is. How much does that contribute to, or are there other components that can contribute to how spin is generated?
Absolutely. I mean, one is the angle of attack, so it has to do with how people pull the paddle through the ball. But from an equipment standpoint, dwell is very important, and dwell time.
Expand on that just a moment.
So this is a key area of measurement in table tennis. Dwell is something that you'll see in every paddle review out there. And we've never really driven that as a discussion topic in our sport, but it is critical in the study of contact mechanics, it's called. So it's basically ball meets paddle, what happens when that occurs. Dwell is the amount of time that the ball will spend on the paddle face. That can be a direct result of how soft the core is, how resilient or hard the surface plies are, a combination of the two materials, the adhesive technology used between those, if it's a heat welded or a standard adhesive. The combination of those things will affect how long the ball can stay on the paddle and how much interaction, whatever roughness or other friction elements might be on the surface, can interact with the ball.
So then, in fact, really what a manufacturer is doing, his secret sauce is really the combination of all of those things.
Exactly. It's not no one thing. I talked to an athlete last night that they actually don't like to see too much roughness. They use a type of grip that it's a Western grip, and they felt with the hard paddle, though, the ball was coming off too quickly. So they're really more interested in how long the ball can remain on the paddle so that they can basically shape the shot a bit better and interact with the ball in terms of how long it stays within their swing, for example.
Something that has come up in events that I do, not a lot, but occasionally, is how much is the ball and which ball you're using affecting how your paddle might respond?
It's very important. So the balls have different hardnesses, different compression rates. The material used, the polymer used in the ball interacts with the surface roughness, the coefficient of friction, or how sticky the paddle surface is. And so you'll see a different result in so many different combinations based on that dwell element that I talked about before, how soft the ball material is. So an injection molded ball is generally softer and will interact a little more deeply with the surface of the paddle, with textures on the paddle. The hardest balls out there will probably compress a bit less and come off the paddle a bit faster, just because they return to shape much more quickly than a softer ball. And then, of course, temperature affects it substantially, actually, and you'll see some balls that perform very differently at different temperatures.
Right.
And then the last piece is on the rotomolded side. So, for example, the Dura or the Franklin X40, those have different shed rates. So as far as contact with the court, a very rough court might tear it up a bit faster. Very rough paddle, same thing. You'll see ball material in the face of paddles periodically, the rougher paddles, and that's essentially being torn off the ball itself.
It's interesting when you talk about shed rate, and it's a fairly unusual term for those of us just in recreational pickleball. But one of the things that I've noticed, and I would be interested in your opinion, is I have been on courts that I sense them being dirtier, grittier, coarser, and it seems to pick up, the ball picks that up, and it grinds on both the ball and paddle faces. Is that the case?
It's true. Yeah, there's a wide variety of roughnesses that you'll see in court surfaces, different shapes of silicate that are used in the acrylic coating. And so those will affect how the ball interacts with the court surface, how much is torn up as the ball skids on the surface. It's not a perfect bounce, by the way, and the ball is not a perfect sphere on impact. It will deform a bit. We've done some tests where we've actually been able to reveal a 2-inch contact patch with a big swing.
Wow.
And so there actually is, can be a considerable amount of deformation in a ball. And then back to your point about the courts, you can start to sense a court that's used a very coarse silicate in the acrylic versus one that's a very fine silicate. And the performance of the ball off those surfaces, the difference in that performance is substantial.
Yeah, it's been interesting to me where over the last particularly 2 years, the conversation has all been about the paddle and the paddle face and the coarseness and the grit, and as though that's the only thing that's a factor, and it sure seems that it isn't. And so I'm glad to hear you report on that. So with all of these things being said, Carl, where we're talking about paddles and balls, particularly of recent, there's been some controversies in the sport of pickleball about equipment. Kind of take us through what that history has been, what caused the controversy, and what your take is as the guy that really runs all the standardization and testing.
So one of the first larger scale controversies was last year. It had to do with a paddle that had the perception of the spin rate off this paddle was that it was far greater than anything else out there. Also, to the touch, it felt rougher as well. I'll talk about textures here in a few minutes. The issue here, the reason why it became a controversy was how it played out and the timing of it as well. It was during a large event, and it meant there was quite a bit of visibility in that. We're very concerned that products following certification are manufactured to those same specs. And so we implemented a compliance program very similar to market compliance programs within other sports. We would discreetly acquire product. We would screen it first. If it failed to screen, then we would do a formal test at our independent labs. And if they failed there, then we would discuss a corrective action plan with the manufacturer. Over the years, there'd been probably 3 excursions or escapes from a manufacturing standpoint that we were able to contain, identify the population of product out in the market, and make a decision on what's next. Do we decertify the product? Do we work with the manufacturer to correct the action and monitor it after that? Do we serialize the product so we can track lot codes or track lots as well? So that process has been improving over the years as well. The first large situation or high impact situation like this, it drew a lot of attention. It was referred to as our first paddle gate, and we learned a lot in terms of how to monitor those, how to implement the corrective action plans as well. And so I think we make iterative improvements to the process over time. And because of the high volume now of paddles using that molded resin surface and the wide variation in the results of those of the manufacturing process, we've had to dial it up a little bit in terms of how often we sample and test and then give feedback to the manufacturers as well. That process, by the way, if a manufacturer passes, then we're the policeman behind the billboard. You never saw us. It's just a confirmation that the quality controls are in place. But we've seen quite a bit of deviation. We'd like to attribute it, and the manufacturers, I think, would like to attribute it to upstream supply chain. So we'll work through that and make sure that there is a quality control process put in place if there hadn't been one or an adequate one before that.
Now, and when you talk about the upstream supply, that seems to me to probably be a very challenging piece of the equation of maintaining consistency that a manufacturer who's using overseas manufacturing might not find out until his product hits the States. Is that the case?
That can be true. We've got so many new brands have moved into the market over the last several years, and many of them don't have manufacturing experience. And so they may not ask the right questions in terms of what is your quality control process, what are the rights of return, if there is a notice of escape in terms of the process and the quality of the product. And so in some cases, the upstream suppliers may not put in place the quality controls that ensure a consistent delivery of product. And so we have discovered a number of those. To help address that, we're working with the manufacturers to develop more thorough quality control plans from a domestic standpoint, but also we're putting in place relationships with many of the suppliers upstream. So
makes sense. Sure.
We all know who they are, and so in some cases they're fairly transparent relationships, and others it may be more challenging. But we're making progress in that area.
So in that area where we're talking about all of the different things that you're working on, and we've had controversy in the sport, how comfortable or how confident are you that the current standards that you guys have in place and your current testing regimes will manage it effectively for the game?
Yeah, if I could qualify the overall processes, at the front end there's a certification process, and those reflect the standards and testing processes that have been put in place. We've developed these to support the board's overall goals of maintaining the integrity of the sport and the quality of play and the nature of play. As I mentioned before, it's a game of finesse. That's the first piece. The tests are conducted by an independent lab, NTS, based in Baltimore. They're a large, multi-location operation, and they've served us very well over the years. The second piece in this the certification and testing pipeline would be market compliance, which I've described as the acquisition of product from the market to test to make sure that the quality controls are in place and that the products being delivered are within, it's called within family, from a specification of the original product certified. That program we're ramping up as we speak, and we've moved the compliance lab into the Northwest, a full library of products that have been certified in the past. We're also enabling that lab to do optical scanning, an acoustic test as well, which we'll talk about later, and some surface roughness testing as well. So we're evolving that. The third piece, it's courtside testing. The ITTF has a program called Racket Control. We've modeled our compliance program after that. We launched it.
Explain who ITTF is.
I'm sorry, the International Table Tennis Federation.
Okay.
At sanctioned events, all paddles are checked, all of them. And so we implemented a program not unlike that at Nationals 1 year ago, and that evolved over the course of the year. We've been supporting both leagues with testing in that area. It initially started off with just surface roughness, which was the main concern at the end of last year. Early this year, there were concerns of delamination in a number of products that resulted in a very powerful paddle. It had a very short life cycle, but it did raise concerns over safety and perhaps an unfair balance in terms of the paddle performances. So we responded within 30 days. We were able to dig into the problem, figure out what would be necessary to be able to identify paddles suffering from this issue. We picked up an ultrasonic bond tester, which is used in aerospace to look at the integrity of the core of panels and things like that. So we implemented that within 30 days and integrated that into our testing policy. The key thing to look at is the courtside testing is a field test. And so there may be more variables there. The practicality of moving lab equipment from site to site is there. The expense of the acquisition of that equipment are all factors to look at what's doable in a given situation. So I believe we responded very quickly to that initial issue early in the year. Since then, this year, we've started to hear about increasingly powerful paddles. They pass deflection tests during the certification process, but they either may have a fast degradation cycle in the field, or they may perform differently under higher stress loads. So we're in the process of evaluating a number of different ways to measure the power off a paddle face. It's called coefficient of restitution. A number of different ways to do that. One we're looking at is an exit speed ratio. Again, that needs to be done in the lab. And so, again, a field test to determine a paddle's power would be very difficult, at least in that same manner. To build a testing or at least an evaluation process around that, though, we're looking at radar, Doppler radar, as a means of evaluating how fast the ball is coming off players' paddles. Now, again, that's not a pass-fail thing, but it gives us usable data where we can look at essentially a data cluster of several paddles, several different players, and if in most cases they'll fall within a cloud that looks like this, there's probably going to be a number of outliers that we can use to at least follow up with further research and maybe identify that paddle, send it back to the lab for a proper coefficient of restitution test.
So on that order, you're hitting on one of the probably the most common questions that I get in my involvement with working with Selkirk and meeting a lot of players and people, is they think in terms of ball speed off the paddle, which you're talking about. There was an interesting analysis that was done. Somebody had done sort of the physics numbers on what happens with the speed coming off of paddle, two players in the no volley zone opposed to each other, 14 feet apart, and what the rate of speed that is.
Yeah.
And we're comparing it to baseball, to a pitcher throwing a 90+ mile an hour pitch.
Right.
Is that an accurate way of beginning to gather how fast this ball is really coming, what our reaction time is in ability to handle it?
It is, and actually we've looked at this a few years ago, back during some my live streaming days, and evaluating footage from the kitchen. And with that, and looking at the frame rate and the amount of time between contact to contact, it became apparent that the fastest shootouts were around a quarter second between contacts. An average high-level shootout could be around a third of a second between contacts, and that's the reaction time required. When you map that to other sports, could be equivalent to the world's fastest pitch. And equivalent to the world's fastest first serve. And the difference, though, between those activities and ours is that there's only one of those, a fast pitch, and you only have to respond once. In ours, the shootout can be 3, 4, 7 shots back to back. And so the demands for reaction time and the physical response to that are significant. And so it begs the question, how fast is too fast? And where does it become a safety issue? And so there's a subjective element to that we need to understand. And I think, talking to a lot of the pro players, we do get pretty transparent feedback of what they think a paddle that might be considered dangerous would be. And then what we can do is some tests around that to identify just what the coefficient of restitution is off of that.
And coefficient of restitution is speed off the face.
It's power. It's power. That's right. It's the return of energy after contact.
You've mentioned some very specific scientific, mechanical testing processes. Would you kind of take us through some of the equipment and the things that you do that we'll later see in the visuals, but tell us about those pieces of equipment.
Sure. I think the one nearest on the horizon is the transition from mechanical stylus that we've used for several years to test the surface of the paddle. The roughness. The way that's been used is 6 axes of measurement, and then it's been averaged for a maximum 40 RT, it's called, which is the peak to valley maximum, and then it's a maximum of 30 RZ, which is an average of 5 samples. That's served us very well over the years, and the challenge that we've seen more recently is these molded surfaces are showing up with different patterns, slightly different than the original fabric that they were intended to mimic. And so we've been evaluating a number of different optical scanning platforms over the last year or so. We acquired a platform that we were comfortable with. It has a very slick software package with it, and our lab has purchased one as well. We're in the transition now of identifying and correlating data of paddles that we consider legal or that have been tested legal and we don't consider too rough. We are looking at ones right up at the limit, different shapes, different surface textures, and then we'll create a transition plan to move from that metric, RT and RZ, to an S value, which evaluates a large area that's been scanned. And that'll give us a much better characterization of the paddle texture and how that interacts with the ball. The 6 axes test has served us pretty well over the last several years, but it's time to transition to something that gives a more comprehensive look at the face. That's on the near term. The measurement of power that we talked about before, the deflection test has served us very well for several years, but because of the advent of a number of paddles that do deliver a bit more power off their face, we have to mature that test a bit, and like I said, we'll move to something. Our labs have been testing coefficient of restitution for years in baseball and golf. We'll probably adopt a similar ballistic style test with an exit speed ratio in that case. The number of variables that need to be managed are significant, and of course that doesn't lend itself well to a field test. So we'll need to look for a facsimile of that we can execute in the field.
Very interesting. You know, one of the things that's been going on of recent, I'll have some episodes coming out about the international explosion in the game in some of the different national or international organizations. Will the standards that you're working on and develop, will those extend worldwide to different organizations that will be falling into the World Pickleball environment?
The practice previously has been that the international governing bodies have adopted the standards that USA Pickleball has invested in, researched, and maintained over the years and curated. We can assume the same thing for the recently announced GPF.
And so it is, with that, really the last question before we go to the lab is, I really kind of like to get your opinion on, where do you think the sport will go? What will be the next evolution, either in terms of material science or product development? Any sense of where you think it might go from now?
Yeah, I think the beat rate of material evolution has picked up. Configurations of paddles have been evolving, which is very exciting. I grew up in the tennis and racquetball boom years and saw quite a significant set of transitions across those sports. Some of those were good, some weren't. And so if you've ever been on a Zoom call with me, you'll see a bit of a museum behind me. It's both a museum, but it's also a cautionary tale. We have to keep a very close eye on these, on what's important, ensure that the right fences are put in place so that development doesn't exceed those goals of, again, maintaining the integrity and the nature of the sport. So that Zoom background that I use is kind of a constant reminder that to keep an eye on that. Sure. And to make sure that we don't lose sight of the overall goal here. Where I see the significant potential is in analytical platforms. We don't understand much about the sport. We talked a little bit about our increasing understanding around the physics of the sport and implementing swing weight machines and things like that. That's very exciting, that kind of a lab-based thing. But I think the understanding of the strategies of the sport, the patterns that emerge, and really data-driven understanding of what it takes to win. And I think there's a couple platforms out there that are being developed that I think may apply, hopefully sooner than later, to help create an environment where both from a understanding of the pro athletes, but also as a teaching platform, helping people understand where they can improve and what areas they should be focusing on. So I think data is probably our biggest opportunity from a performance standpoint. And then one other gap that's near to my heart is really understanding the impact of the sport on our physiology, on the health side. And I think there's been some research. The recent APRA report was useful, but there's so much more that we can learn in terms of this sport. And this sport delivers so much from a health standpoint. There's very few others that are like this, that deliver an activity that has the frequency, the duration of play, and the intensity that our sport has. And that combination really is a driver behind physiological change and improvement. And I'm hoping that there'll be some research around that'll help advance our understanding.
Very cool. You know what I think we ought to do? I think we ought to take a break. Let's go into the lab. Let's see what this stuff is that you've been talking about.
Sure.
To the best of my knowledge, no one has ever seen this stuff other than we've never had a broadcast that I'm aware of that covers this stuff, has there?
No, there hasn't been. The athletes see it all the time. We have a
Right.
very transparent testing process. They know what's being tested. They know what the results are. But from a broadcast and media standpoint, no, this hasn't happened. Yeah.
Let's go into the lab, see what this is all about. Well, we finally made it to the lab. Carl, I'm anxious to see what you've got going on here. And the fact is, no one else has really seen this other than pro athletes. Welcome to Carl's haunt.
Thank you, Paul. So over the last year, we've been providing compliance testing support to both tours as well as several USA Pickleball events. The testing that we have in place today consists of both the surface roughness test. This is a Starrett SR 300 that we use to test the overall surface roughness. It yields a nice pattern in terms of what the peaks and valleys of the paddle are. The other piece of equipment that we use for testing is a Olympus Bondmaster 600M. So this is a piece of equipment that's used in aviation and aerospace to test the integrity of panels. We use this to look at essentially the core integrity of a paddle. In some cases, paddles can break down fairly quickly, resulting in a very active face. We put this in place earlier this year when it became apparent that a number of paddles were suffering from very fast deterioration, resulting in a very powerful face. And so it's been very effective at identifying issues like delamination, disbonding, and crush core through the course of the year. This technology that we use has been in place for several years. Because of the advancements in surface roughness patterns, we've been evaluating a technology called an optical scanner. That technology has been around for several years. It's very mature actually, but it is a very from an advancement standpoint, it's fairly new in our space. So what this does is it uses a green light interferometry scanner. With that, it yields quite a few data points that we can use for analysis. So this is what it looks like from above, and then all that data can be mapped into a three-dimensional image, which we can evaluate much more closely for detail. Now, the transition that we're planning with this is moving from an R value, so RT and RZ or something that we measure today at our certification and also in this compliance testing. But the migration will be from an R value to an S value. And so we're looking at several different elements, either ASME, EUR, ISO standards. One that we believe will be very appropriate for this would be a developed interfacial area ratio, which means how much more material is exposed with this surface texture to the ball. So this is in development. We're working on corollary testing in this space, and our lab is assisting us, of course, in this, and we anticipate migrating in the first quarter of next year. I'd like to introduce Gary Toribio. Gary's both an ambassador with USA Pickleball, but he's joined the team here testing paddles at the USA Pickleball Nationals. Gary's going to run these paddles that were just dropped off by Pablo Tellez just a moment ago, and we'll show you just what the process looks like. Gary?
So the first thing we're going to do is check the core integrity with this Bondmaster 600. We start off by checking the gain and the frequency on the paddle. First thing we're going to do is change the frequency a bit. So we'll take that up to 21 hertz or kilohertz. Okay. Then we're going to look at the RF gain, and what we want to do there is stay within the yellow line parameters. So I'm going to turn that gain down a little bit. So we're just touching it, okay? Now we'll zero it out, and now we're watching the yellow box, and we want to see how tight of a pattern that we get. Tight pattern means it's got a good core integrity. Okay, so that's a good core there. Okay, next thing we're going to do is take the device for the roughness, And we'll first test the paddle at an angle of 45 degrees across the face. So now it's measuring it. And I don't know if you could have seen it, but that needle moves slightly back and forth. We can do it again.
Very interesting.
Okay. That's too low of a reading, so that's not a good example. It's too low. It should be in the 30 micron range. Yep, 36.74 for the RT. The RZ is 21.2. The maximum range by the specifications and the rules is 40 microns. So this meets the roughness standards as well. The last thing we're going to do is put a USA Pickleball certification sticker on the paddle. And that's specific to this, I'll just put it over here. Specific to nationals. Okay. And then the last thing we do is take a photograph for the records of both the paddle and the results of the core integrity test. And that's it. So that paddle passed.
All right, another technology that we've been evaluating to gain a better understanding of the physics of ball meets paddle is radar. Recently, we were introduced to Stalker Sports, and Grayson Ginesta has walked us through how to use these devices. This is a top-end radar gun used in, today it's used in MLB by scouts. We're looking at adapting it for this sport. We use it for both inbound and outbound speeds. Of course, with that data, we can calculate exit speed ratios, but this will also capture spin rate. Clearly, this is not a lab-based test, but what this does is it allows us to collect a lot of data in a very short period of time and essentially create clusters of data that we can look for outliers, which can then set up an opportunity to test that product later on.
Carl, could I ask you a quick question? One of the things that has been a big factor in the sport has been spin rate. And I know Chris Olson at the Pickleball Studio has used measuring rate of spin on video. Is that more or less accurate than this would be, or would it be different?
He uses an optical approach. He has a marked ball and he measures the rotations. This uses Doppler radar. This has been, it's a mature technology. It's been used in many different industries. Stalker Sports is evolving this though with software updates. We're really looking forward to working with them to set up the right parameters and how to measure our sport more accurately. We anticipate using this at more and more events, both in the field, but we'll use this probably in combination with an optical platform to test coefficient of restitution in our lab here in the near future. So we're very excited to use it here at our USA Pickleball Nationals. The other aspect of this, along with this information, there's an app that runs on a tablet, and this will present the information to the on-air talent so they can inform the spectators spin rates, high-speed serves, and return of serves. So we're very excited to apply this technology. It's used in many other sports. It's the first of its kind here applied in pickleball. So to complement and correlate the data that we gather with the radar guns, we also have a high-speed camera. It uses a very high frame rate, up to 1,000 frames per second, and we'll use this to record the video alongside with the readings that we take with the radar guns from Stalker Sports.
Carl, let me ask you a question. When you're describing some of this equipment, do you think as this stuff comes online, we're going to see changes to what we think are existing standards?
This will more than likely complement existing standards in terms of our understanding of what they mean or how they're implemented in play. And yeah, they'll help advance the ball in terms of development of the next generation of standards. And one thing to make very clear, We evolve this at a rate that is absorbable by the industry. One of the things I tell people is that it's very important that when we're talking about product development and policies that impact inventories in the field and what's next from a product standpoint, that we make no sudden movements. We want to make sure that the industry is aligned, supportive of the direction that we're going, and has had input in terms of the decisions that are made around it. To finish our tour, we're going to take a look at a piece of equipment that's used in many other sports to help dimension and understand the physical aspects of a paddle or racket. This is a Wilson Biordo Tune. This device does weight and balance. It also does swing weight. And so just to run you through how it would be used, an athlete would bring us in a paddle. It might be their Goldilocks paddle that has their perfect weighting. This gives us a chance to dimension it, give it to the athlete so that when they get their next set of paddles from their supplier, they can weight it up exactly the same way each time. So the balance piece of it here and weight, use a very accurate scale. It'll generate the weight for you here and the balance where the fulcrum is or the midpoint is on the paddle. From a balance standpoint, you can see this one weighs 8.1 ounces and the balance point's at 9.6. If we want to go to a proper international standard or measurement, 230.5 grams, 24.3 centimeters. The next piece that we want to look at is the swing weight. And so this is also known as the moment of inertia. This is basically how a paddle feels in your arm is an extension of your swing. For those athletes that have very developed stroke mechanics, this swing weight is very important. It's, of course, an area of focus in tennis and golf. The way this works is once it's mounted, you cock it back like this, release, and if you come around, release, and it delivers a swing weight here of 76. You add a little bit of weight here, down near the hips of the paddle. It won't change the swing weight that much. If you add the weight up here around the shoulders of the paddle, it will impact it significantly. All right, that ends our tour. Thanks for joining us.
What a cool tour.
Yeah, thank you.
I've got to tell you, I have looked forward to doing this, to get the opportunity. I know it was unique for me to actually have seen this stuff, but it's been fun as we've been prepping for this showcase of what really goes on in the USA Pickleball testing and analysis. Very, very fun indeed. Thank you so much for taking us through that. Now I'd like to segue into the other side of your life, which is facility standards. All of the things that go into that side of the game, and really a big one that I think we need to talk about is what's going on with sound in the sport of pickleball.
Sure.
But before we touch on sound, what are the other components of standardization that you deal with in facilities and equipment?
So we work very closely with the American Sports Builders Association, and for the last 4 years or so, we've been publishing Court Builder's Guide, and that's been essentially the Bible in terms of dimensioning, overruns, looking at footings, fencing, nets, everything it takes to build a court. And we're just finishing up an editing process on the most recent edition of this, and it'll include a category to address amenities in facilities, which would include, it's mostly targeted toward those that want to host events. And more often than not, when someone approaches us for advice on building a facility, they also say, we want to host large events, regionals, professional competitions. And so you need to take into account things like, where do vendors go, crowd, traffic movement, where's operations go, referee accommodations, all these things that may not be considered when you're initially designing it. So we've created a chapter to address that piece, and then another chapter, or at least data, to address the acoustic piece, which we'll expand on in a moment. Other than that, there's some subtleties in facilities design that may seem like little things up front, but the first time you walk into a facility and experience the downside of poor planning, it can be high impact. And things like color choices. We're really big fans of cool, or darker greens and blues. The contrast ratio of that background to a ball is significant, and it makes it much easier to see. Reducing clutter is very important. In fact, back to colors, the number of colors chosen. So, very different kitchen, service field, and out-of-bound colors create a situation where the eye has to adapt each time that ball crosses in front of a different color. The color red, should only be used as a highlight, not recommended for kitchens, service fields, or out of bounds, because that excites the rods and cones of your eyes and leaves after images. And so a player, paying member, may experience eye fatigue or not play well as a result of that, but not really know why, because it's not, it isn't something that you pick up right away, but the eye has to work harder to pick a ball up off a bad, either a cluttered background or poor color choice like that. So little things like that are important. And to your point, our facilities development group, what we do is we'll try to engage as early as possible to make sure that we understand the scope of the project. We'll help them with economic impact data, demographic data, planning around basically the pitch up front if they have to go out and acquire debt to pay for it. We also blend in some learnings from mistakes made in other booms, and that's spending too much too soon. And so I come from the racquetball industry, and I look back on that now, and what we try to advise is a crawl, walk, run approach, or at least a gated approach to building out facilities. Phase one is a proof of concept, and you might be building a membership and testing a market. When you reach a certain point, then expand from that. But overbuilding too soon, very, very poor results in the tennis and racquetball industries back in the 80s. So we try to help them through that planning process. We work with an external entity called Ground Rule. That's a series of companies that works with the USTA and MLB in facilities design and development. For larger private projects, we'll engage them, and they'll help with feasibility studies, an independent feasibility study, which is required to acquire debt, right? So, or external investments. And so that program's been ramping very well. We've got in our pipeline close to $300 million in projects that we're working with. It might be a small touch or it might be deeply involved, but we're finding getting engaged early is very helpful. And then many of these facilities are being considered in parks. So if it's a municipal engagement, the first thing that we'll ask them to do is let's look at this from an acoustic standpoint. And so we'll help them with a simulation, looking at where they want to put if it's a conversion, obviously it's you can identify the distance right away. If it's a greenfield, it's called for a new construction, then we'll evaluate the property for the best possible placement to reduce the acoustic impact of any surrounding residential areas. And if necessary, we'll bring in an external acoustic engineer. We work with several. If there's a third party required to do that. And then if it looks like the placement of a facility may require mitigation, we've engaged with several suppliers of acoustic panels with 4 different technologies: suspended acoustic foam, mass-loaded vinyl, sound attenuated fabric, and then there's a couple of providers of modular acoustic barriers that include clear panels that are still reflective of the acoustic energy, but it allows a drive-by park ranger to look in to make sure from a security and safety standpoint
that makes
things
sense.
are good.
Yeah.
And so that's on the facility side. This acoustic program has also, a key component of it is equipment.
Right.
So to round out the question here, the answer to your question, and that is we've spent 15 months working with several external acoustic firms to evaluate the nature of the noise of a ball coming off a paddle. So obviously the sound pressure measured in decibels, from a spectrum standpoint measured in hertz, and then the time domain, how fast is the sound created and how fast does it taper. All 3 of those are very important components in evaluating the equipment, both balls and paddles. And so we've been working with many recognize the name Bob Unitic. He's a certified referee, but he's built a practice around evaluating equipment and facilities for acoustic propagation. So we've come up with a specification. We just published this earlier this week, and gotten many calls from manufacturers that are ready to pull the trigger and move in this direction, which we're very excited about. We believe the first couple of products, which were already in development as we were trying to finalize the numbers, will probably be announced within the next week. And then many of my conversations with larger brands have been moving forward very quickly in terms of developments in this area. We're really excited about it. We both understand or believe that this will help address this possible barrier to growth, the perception that the sport's noisy. This will help reduce that, the characterization, we believe, and will definitely help solve some facilities that have been shut down because of residential or nearby residences complaining about it. So we're very excited about it, and we believe that there'll be a number of products released this quarter.
Now, when you talk about that caliber of product, new innovations, what does that do to the performance, feel, touch, power that we're used to seeing with product? Will that change? That
was a significant driver behind where we landed on the specification. So in addition to the acoustic specifications, we knew that some materials may need to be used to drop it below the threshold that we felt was a significant impact. We didn't want to just see a couple decibels or a couple hundred hertz. The new specification is about 10 decibels below some of the louder paddles out there, and it's about 600 hertz below what you hear from a loud, typically lower cost paddle. The result of that is a perception of half as loud. And so that's the marketing reference.
Okay.
Rather than going through the numbers with anybody, it's about half as loud as what you're used to hearing. And so the release of these products we'll see over the next couple of weeks, the first ones, and the development time has been significant in terms of the specification itself. To finally answer your question, the playability was very important to us. There have been a couple of attempts, solid attempts to reduce the noise of the sport through different technologies and configurations with the paddle. But the result was a paddle that some didn't consider delivering a true pickleball experience. And so what we've done is, with a little bit of specification relief, a slight increase in deflection, but still very controlled, and a slight increase in coefficient of friction, and a relaxation of some of the materials that can be used on the surface of the paddle, it's resulted in a paddle that can deliver that 50% reduction and still play like a regular paddle. I spent several hours hitting with the first one that you'll see here in the next week or so, and that's a consideration when we look at any of the new paddles coming out. But we believe those specifications will help ensure standard pickleball experience in terms of playability, but will substantially reduce the noise level.
When we talk about this noise level issue, I remember quite a few years ago, maybe 8, 9, 10 years ago, was the first time that I ever knew of the sound issue coming up in some HOAs. And in those days, if you'll recall, we had an aluminum honeycomb core that started to put a graphite face on a paddle that was loud. There was just no question about it. And I think it may have even gone to court, but I believe that one of the big mitigating factors was the player voice volume. That one of the things that's joyous about our game is we have a lot of fun, and we have a lot of, and I think it actually kind of took away some of it, is that noise volume that's created by us having fun, a great point, there's an eruption after the fun. That's got to be as much noise as anything that's coming off of a paddle, isn't it?
That's true, and where this has become an issue is primarily community parks, or what we call pocket parks. These are the small parks that during tennis's growth back in the 70s and early 80s, many communities put in 2 courts.
Right.
It was about 120 by 110 square foot, those are the linear dimensions of this facility. And because many of those have gone into disuse over the years, that corner of the park has become quiet. and then you convert 2 tennis courts to 6 or 8 pickleball courts, suddenly you go from an area that wasn't being used, or even if it was being used, there was a maximum of 4 to 8 people. Suddenly that facility can hold up to 32 people at one point in time, with another group of people on the side waiting to mix in. And so you have a higher density of player there, and it's a very vocal, it can be a very emotive sport. And so that's, I think, exacerbated the problem and the perceptions as well. And then one thing that you didn't mention, that's parking. Was that facility or that park designed for that many more participants there? So those are elements that do add to it, and we can't affect the joy of the sport.
Sure.
But that is a good observation. That is a component of it.
But I've wondered if, so we have small pockets, to the best of my knowledge. We have somewhat isolated. It's an HOA. What's the distance from the units to the property? Was the person in there before the courts were there, when there was no noise? And do you? I guess at the end of the day, the real key is: will this affect a person that lives in an HOA that likes to play in tournaments? Will there be a difference between maybe a product that they want to play at a major national event that's approved, but they're living in a place with that has limitations? Will that be something that people will deal with in terms of performance?
Yeah, 2 answers to your question. The first is, right out of the gate, we'll see products that come out that will carry a quiet certification.
Okay.
But because they've received relaxed specifications, they won't be usable in sanctioned competition. That doesn't mean that development isn't underway and that we'll see eventually paddles that both meet all certifications, but also they're below those thresholds as well. So they'd earn dual certifications. And so that's the kind of the holy grail, I think, in time. But we had to crawl, walk, run, to get into that space. Bigger picture, by the way, in terms of communities and codes and things that are applied, and distance setbacks and things like that. You're right. It's not the thing to look at is that it's an equation. If the target is 60 decibels, that's what the ordinance is. It isn't a given that the courts be 350 feet away. There's a number of factors. Is the ground soft, or is it hardscape between them? Elevations are important, prevailing winds. There's a lot of variables that go into evaluating where a facility can be put in proximity. But where we start is, what's the current code? Is it zoned for recreation? Is the daytime limit 65 decibels? And then we start with that. There's another layer of characterization that this is an impulsive noise and that it should carry a penalty. Before we go down that path, what we're trying to do, and we've done some research in this area already, is bring in more qualitative and quantitative research into it, but also look at studies done by NASA on auditory localization to make sure when analysis is done of a potential site or an existing site, that the different contributors to that auditory, to that soundscape, are properly identified. And so, yes, the pickleball courts at 100 feet or 70 decibels, but with what's called an ambisonic mic, it's got multiple capsules. You can identify that the reflection off the houses behind contributes another 3 decibels.
Wow.
And the flyover of aircraft contributes noise as well. So you have to look at what's the real ambient soundscape, and then you work down from an engineering standpoint. You drive down the sound propagation from the acoustic propagation from the courts. And so looking at that NASA study, applying that to how we evaluate it, but also we're talking to acoustic engineers, in fact, and I've been engaging with the social media, on the social media platforms with antagonists in this space. They're more or less support groups where people have been affected by it, and it's a real thing for them. We can't sweep it under the carpet and say you should just go play. It's not that simple. These sounds can affect people in a way that definitely bothers them. So for you it's Bach, for me it's Bachman-Turner.
Yeah.
Right. And
yeah.
so that's an important
Yeah.
thing to understand. And so when trying to address these situations, we have to look at many different components. We have to also understand what exists from a existing code and ordinance, what can be changed with that. And so it's a complex process, and I think with the input from a couple of very sharp engineering firms, acoustic engineering firms, listening to these people that do have issues with it, we don't want to take a defensive position at all. We want to understand what their concerns are. We want to take a realistic approach to it as well, though. 1,000-foot setback on either side of a 120 square foot facility is an 80+ acre parcel.
Right.
And there are not many communities that
Sure.
have that much space.
Sure. Carl, thank you very much. This has been a terrific interview. You have covered so many key elements that I think our marketplace is looking for these answers. Mm-hmm. Ladies and gentlemen, I told you it was going to be a fun meeting today. Carl Schmits from USA Pickleball, the governing body of the U.S. and the governing body of the worldwide of pickleball. Thank you very much.
Thank you, Paul. Appreciate it.